So the overall steps are pretty much identical to the Arid West method. You want to do some desktop recon first. You want to prep your sampling gear. When you get to the site, you want to walk the reach to determine the reach size and placement. And then you want to start measuring your indicators. So the desktop reconnaissance, it's a great opportunity to gather all the information you need. You want to determine, safe access routes. You want to make sure you've got property owner permissions if necessary, and just determine if there are any safety concerns involved with assessing the site. It also helps you gauge field conditions, whether it's going to be, a steep and rocky climb, or you have to hike through snow to get to your site. You can begin to figure out how many assessment reaches you're going to need and where you might place them. You can start gathering other information related to flow at your reach. You can find, for example, regional plant lists or wildlife observations, see if there's a gauge nearby. You can actually measure a handful of indicators in aerial imagery. We'll talk about this more with the specifics of each indicator, but you can start getting a sense of what they're likely to be based on your desktop recon. And you can finally, and perhaps most importantly, begin to identify local experts who might know something about your reach. So historical imagery can be really helpful for assessing stream flow duration. This doesn't work at every site, but you can, at some sites, observe the presence of flow in a channel under different time periods and get a sense as to how often a reach dries up. Do keep in mind that the dates reported in Google Earth, which is a great way to access historical imagery, these dates are not always accurate, so you probably want to just use it as a approximate timing of when conditions were wet or dry, although I wouldn't necessarily tie them to a specific rain event. It can also help you figure out if your site experiences snow. We've got our web app that also helps measure this based on long-term conditions, but this can also tell you, when is that snow likely to occur. If you're trying to assess the site in December, you probably need to, pack differently than if you were to go there in September. The sampling gear you need for this method is pretty much identical to the gear you require for the Arid West method. And in general, you don't need big bulky gear. One person can carry it all. The biggest item you need is a D-frame net. Although even with that, you can substitute a smaller aquarium net for certain applications if necessary. But yeah, the list of sampling gear is more or less identical for the two methods. As always, make sure that your gear is clean to make sure you're not spreading invasive species or fish and amphibian diseases. There are resources maintained by the USGS as well as the USDA on invasive species that can help you figure out methods to help clean your gear and limit the spread. Also, you can use these to report sightings of these species if you encounter them. This image on the right is the New Zealand mud snail, which is a major problem in several western rivers. So do be careful to look for them. They are minute, but they can cause a good deal of damage. So when you get to the reach, the first thing you want to do is try to walk the full distance to figure out, how many reaches you need. As you start walking up, you begin taking your channel width measures. We recommend doing this at 3 locations. For example, at the downstream end, then 15 meters up, and then 30 meters up. And that way you can figure out how much further you're likely to go. Are you going to need to only go, 10 more meters to get your 40-meter reach, or are you going to have to do the full 200? As you walk up, this is the ideal time for you to look for certain indicators like fish and amphibians, because your activities are likely to disturb these creatures. They're going to hide if they feel threatened by you. So you might have your only opportunity to see them will be on that initial walk. To the extent that you can stay outside the water, your disturbances if you walk in the stream could hinder measurements, particularly for the algae and aquatic invertebrates. once you've walked the reach, you want to finalize where your reach boundaries are, figure out, is it stopping by some bend in the river or an oak tree or some kind of landmark, and you can start drawing your site sketch. Like I said, we measure bank fold channel width at least 3 locations. Determining bank fold dimensions can be a challenge in some settings, but it's defined basically as bank fold elevation is where the channel starts to transition to the floodplain. You see a sharp change in slope, and you should look for a number of other bank fold indicators to help you identify this. The user manual identifies a handful of commonly used indicators, things like water stains, changes in vegetation, exposed plant roots. You want to use what's going to be appropriate for your region. In braided channels, you want to use the entire width of the active channel. So if your site looks like this one, each channel is maybe 2 meters wide, but the entire channel is more like 30 or so meters wide. So your reach would basically be a 200-meter long reach. You should begin recording on your field form the general site information, things like the project name or the site identifier. You want to put down the names of the people who are conducting the assessment, the coordinates, etc. You want to provide a good description of your reach boundaries here as well. You can also talk about the surrounding context around your assessment, things like the weather conditions, land use, as well as disturbances that might either affect flow duration or affect your ability to measure these indicators. Photo documentation is a really helpful part of the assessment. I would say as a rule, more photos are better. We have 4 required photos, basically at the top and bottom of the reach, looking inwards, as well as the middle of the reach looking upwards and downwards. And there's a handful of other photographs we would strongly recommend for every assessment. If you have the opportunity to get a top view from a bridge crossing, it's always really helpful. If practical, taking photos of individual indicators like the plants you're observing, the aquatic invertebrates, the algae mats, any fish you can see. If you want to document the presence of any supplemental information you provide, like amphibians or iron oxidizing bacteria. And finally, any disturbances that might affect the way you measure or interpret these indicators. The field form has an area where you can log all the photos you're taking. So one of the first things that we also like to characterize is the hydrologic conditions at the site, which we look at in terms of the surface or subsurface flow. And you want to estimate this as a percent of the entire reach length. And in addition, you want to look for isolated pools. An isolated pool, it has to be in the channel, so it can't be on the floodplain. It has to have water at the time of the assessment. So if it's dried out, it is no longer an isolated pool. And it cannot be connected. It has to be isolated from flowing surface water. So if it's got an inlet or an outlet, then it is no longer isolated. So here's an example. You've got a stream with surface flow throughout the entire reach. You have this one pool on the side in the floodplain. So we would say that this reach has 100% surface flow. Therefore, it has to have at least as much subsurface flow. So it's 100% surface plus subsurface flow, but no isolated pools. This example is a little different. We have surface flow throughout part of the reach, but the bottom third of it or so is dry. The flow ends in this pool that's within the channel. So in this case, we'd say 70% surface flow. Because there's no evidence of subsurface flow below the pool, we say, again, 70% surface or subsurface flow, and again, no isolated pools. There is a pool and channel, but it isn't isolated. In this example, we have, flow in the top third of the channel. Then there's an area with no surface water, but another pool within the channel, and water is flowing out of that. There's an outlet from that pool. So in this case, we have a little bit more surface flow. We can infer, though, that there is connection between these two pools. So you have 100% subsurface and surface flow. And even though you have these two pools, neither of them are isolated. In this final example, it's basically like the previous one, except this bottom one has no inlet or outlet, and there's no evidence that there's any flow connecting this pool to the one above it. So we say 70% surface flow, 70% surface or subsurface flow, and one isolated pool. Is there any questions about this? The main point of this is to help characterize the general hydrologic conditions that occurred at the time of the assessment. So this plus, a handful of photos can go a long way to help people understand what conditions were like when you were out there in the field.